Another thing had to do with how to, when I send you information, you have to figure out when to listen. When do I get the value off the wire? And I had this scheme that involved a single clock arriving everywhere at the same moment, so everybody saw the same thing. It turned out it was much better to encode the clock information, in other words, when to listen, when to get the value off a wire, okay, in the transmission itself. So it didn't matter where you were, your timing of when to look at the wire was relative to what's on the wire as you see it, not by, how anybody else sees it. The idea is that every time there's a transition, well, that sort of tells you where some of the clock edges were, because the transmitter was using its own clock to figure out when to change values, 0, 1, 1, 0, so forth and so on. So you can infer where some of the clocks were every time there's a transition. And then knowing something about the nominal clock period, you could then infer, okay, when all the other clock edges happened. It turned out there was not a transition here because we were transmitting 1 in both cells. But I can, so long I have enough transitions, and in fact we come up with these careful encodings like the 8B, 10B encoding that guarantees enough transitions that this clock inference mechanism works correctly. And in fact there's electronics at all these communication links now that are doing this sort of clock inference. And then we carefully choose to take the value out of the middle of the clock cycle to avoid any effects of the changing of the signal. And this allows us to achieve quite high communication systems without having to include a separate wire for the clock, or in fact having to take into account skew at all. Each of you is making your own determination about when to sample the signal based on the signal that you're looking at.